Hey everyone, ever feel like math has its own secret language? Well, today we're going to decode it. We're pulling back the curtain on the hidden rules that run everything from simple fractions to complex formulas, and I promise this is going to be fun. All right, let's just jump right in with a question that I'm sure has made you scratch your head before. What's the deal with fractions? Why is it that when you divide 3 by 4, you get a nice, clean 0.75, but when you divide 5 by 6, you get this decimal that just goes on forever? It seems totally random, right? Well, it's not. There's a secret code at play here, and today we're going to crack it. So, first up, let's unravel this decimal mystery. We need to get to know our two main suspects here. When a fraction becomes a decimal, it can only go one of two ways. On one hand, you've got terminating decimals. They're great. They have a clear finish line, like 1 divided by 4, which is exactly 0.25. Done. But then, you've got repeating decimals. These guys are the marathon runners of the number world, repeating the same pattern over and over, forever, like 1 divided by 3. And here's the cool part. Both of these guys, the ones that stop and the ones that run forever, they both belong to the same big family. We call them rational numbers. And all that means is that it's a number you can write as a simple fraction. So whether it terminates or repeats, if it started as a fraction, it's rational. Okay, so we know who we're dealing with. Now it's time to crack the case. And believe it or not, the clue has been hiding in plain sight the whole time, right inside the fraction itself. And here it is. This is the whole secret. It's all hidden in the prime factors of the denominator. That's the bottom number of the fraction. That one spot tells you everything you need to know. This is the 3-step test that works every single time. It's foolproof. First, simplify that fraction down as far as it can go. Second, take that new denominator and break it down into its prime factors. You know, the prime numbers that multiply to make it. And third, here's the moment of truth. You just look at those factors. If the only prime factors you see are 2s or 5s, that's it, just 2s or 5s, the decimal will terminate. But if you see any other prime number in there, like a 3, a 7, an 11, it's going to repeat forever. Let's see this rule in action. Take 6 over 40. First, we simplify it down to 3 over 20. Okay, what are the prime factors of 20? Well, it's just 2s and a 5. So our rule says the decimal has to terminate. And it does. Now, what about our original mystery, 5 over 6? The denominator is 6. Its prime factors are 2 and 3. And that, right there, that little number 3, that's our culprit. It's the reason 5 over 6 repeats forever. Mystery solved. Okay, now that we've cracked that code, let's level up. We're going to add another super powerful tool to our math kit, the laws of exponents. These are the shortcuts that make big, messy numbers suddenly become easy. I absolutely love this way of thinking about it. Exponent laws aren't just some boring rules you have to memorize for a test. They are the grammar of algebra. Once you know them, you can speak the language of math fluently. You can take really complicated-looking problems and simplify them into something, well, something elegant. Let's look at 3 of the big ones. The product of powers rule just says that if you're multiplying and the base number is the same, you just add the exponents. Easy. With the power of a power, you just multiply the exponents together. And with the power of a product, you apply that outside exponent to every single thing inside the parentheses. Okay, let's put that first rule to work. Say you've got 3 squared times 3 to the 7th. No calculator needed. Just use the rule. The base is the same, it's 3, so you just add the exponents. 2 plus 7 is 9. Boom. The answer is 3 to the 9th. See how much faster that is? Now for a trickier one, using that power of a product rule. We have 2x squared y cubed. That little 3 on the outside? It's like a party invitation for every single thing on the inside. So 2 gets cubed, which is 8. X squared gets cubed. We multiply the exponents to get x to the 6th. And y gets cubed. Put it all together, and our final clean answer is 8x 6th y cubed. So neat. All right, we've cracked the decimal code. We've learned the grammar of exponents. Now for the main event. It's time to combine everything we've learned and really master how to simplify these big algebraic expressions. Now, the number one most important rule for this next part is understanding like terms. It's actually super simple. You can only add or subtract things that have the exact same variables raised to the exact same power. Think of it like sorting laundry, you know? You put all the x squareds in one pile and all the regular x's in another. You just can't mix them up. Okay, here we go. This is the big one we're gonna solve together. It might look a little scary at first, subtracting one of these things from another, but trust me, it's just a puzzle with a few easy steps. Step 1, and listen up because this is where almost everyone messes up. When you're subtracting that whole expression in the parentheses, you have to distribute that negative sign to every single term inside. It's a game changer. So that positive x squared becomes negative, and that positive 3x, well, it becomes negative 3x. Okay, now for the fun part, sorting everything out. We're just going to group all our buddies together. We'll grab the x squared terms, that's 3x squared and negative x squared. Then we grab our plain x terms, that's negative 2x and negative 3x. And that little number 1, the constant, well, it's just hanging out by itself. And finally, we just put them together. 3x squared minus 1x squared leaves us with 2x squared. Then negative 2x minus 3x gives us negative 5x. And the 1 tags along for the ride. And there you have it, our clean, simple, final answer. 2x squared minus 5x plus 1. Beautiful. Wow, we have covered a ton of ground, from decimal mysteries all the way to big algebraic expressions. So let's just take a second to look back at the awesome new tools you've just added to your math toolkit. So here are the 3 big ideas to walk away with. First, you now know the secret to predicting decimals. It's all about those prime factors, 2 and 5, in the denominator. Second, you know that exponent laws aren't scary. They're actually incredibly powerful shortcuts. And third, you know that the real key to taming those big, messy expressions is just sorting and combining like terms. You know, if there's one thing I really hope you take away from all this, it's this. Math isn't just a hunt for the right answer. The real magic, the real power, is in understanding the pattern, the logic that gets you there. You've learned to decode fractions and master the grammar of algebra. So the real question isn't about what we learned today. It's about what this new understanding empowers you to discover tomorrow. What patterns will you find next? Thanks so much for joining me.